Hello all, example 1, 2 and 3 are very straightforward. I actually don't expect any of you to watch this, but for completion's sake I'm doing it anyhow. The question in example 1 is to draw a line segment with this vector 3 minus 2 and state the magnitude of the vector. So the whole point of this question really is just showing you that it doesn't matter where the vector starts, it just matters its size. Okay, well how does it relate in regards to base vectors, so to speak. And in this case we're going to use the typical x, y axes, and this is just a clip I've copied out of GeoGebra. And so I could move A or B around, and it doesn't matter as long as it moves across 3 on the bottom. So that's 3 in the x direction and minus 2, so 2 down in the y direction, and they're both doing the same. So the question is, what is the magnitude of that? Well, so if, let's call it u was equal to 3 minus 2, then we could say the magnitude of u is equal to the square root of 3 squared plus minus 2 squared equals 9 plus 4 is 13, root 13, 13 to prime. So I'm going to stop right there. Okay, so that's all you need to do for example 1. And that does relate to some questions in your book. But I'll mention that at the start in the main video. Example 2. We're given this line segment from 2, 6 to 3, 1. If u is equal to AB, find AB, right? So in other words, u is just the line, and I've already did this one in GeoGebra as well. And so you should see that that point there is, so what did that just do? So this point here is 2, so I've got 2 down the bottom, 6, so that's 2, 6, and the other bit over here is 3, 1. What was I thinking? So it's moved across 1 and it's moved down 5, so that means that u must be equal to, so we moved across 1 and down 5. Excuse me while I swear. Okay, I had to fill that in. This pen is being a bit annoying. So we're asked to illustrate the vector sum here of these vectors. So it should be obvious that the last one here is B, and the first one is B, the last one is C, first one is C, so to speak. So these are all going to connect. So if I was to draw my points here, let's use a different color. So I've got A, B, C, and D. So A to B is this thing here. Ooh. Okay, so that's A to B. And from here to here, we've got B to C. And from here to here, we've got C to D. Okay, so there's nothing controversial here. So yeah, just so it turns out that if I add all these vectors one upon each other, then this one here is, so from the start of this one to the end of all of them put together is the new vector, is a vector sum, right? So in other words, this is telling me that A, B plus B, C. Come on. Why are you doing this to me? Alright, plus C is equal to A to D. Okay, so in other words, when you've got all these little connectors going on here, then really we just end up with the two end ones, don't we? All right, that was exciting. I'll see you in the main video though. Bye.